We say that two lines are parallel if they're in the same plane and never intersect. As such, we can be a little more specific about what it means for lines to be parallel, where we say that two distinct non-vertical lines are parallel if and only if they have the same slope, and two distinct vertical lines will always be parallel. Where that phrase if and only if is an important one in math, it means that if I have the first, then I have the second, and if I have the second, then I have the first. It's saying that it goes in both directions. One implies the other implies the first. They are equivalent statements. They mean exactly the same thing. Where the etymology of the word parallel kind of tells us what's going on here, as the Greek that it comes from, because parallel lines are something that have been discussed since the time of Euclid, translate directly as something like alongside each other. So parallel lines are lines that are alongside one another, where we're kind of making the assumption that we're working within the reasonable geometry that we're used to, the Euclidean geometry that we're used to. Again, I like to put some hints in here for things that most of you probably won't see, but if you're curious and if you're going to go far with this stuff, you may get to where in other types of realizations, in other ways of thinking about space in more spherical and hyperbolic ways, the idea of parallelism doesn't quite work in the same way, because with all those curves, you don't talk about straight lines being the fastest way to get from one point to another. You have these things called geodesics, which are special curves that minimize distance, but again, that's way beyond us. So let's just take a quick example here of how parallel lines work in our more comfortably flat two-dimensional space. So what we want to do here is write an equation of a line passing through the point -3, 1 that is parallel to the line with equation y equals 2x plus 5. So what we can do here is use point-slope form, where we are given the point very directly, -3, 1, and indirectly we are given the slope, where the slope here is, well, 2. Because it's parallel, it has to have the same slope. So, our line will have the equation y minus 1 equals 2 times x plus 3. Where from there, if we want to get it into a nicer form, we want to get into a form we like a little bit more, we can multiply some stuff out, throw a y over, and we get that y is equal to 2x plus 6 plus 1, or y is equal to 2x plus 7, as we'll have for our line. And the next thing we're going to talk about here is the closely related cousin to parallel lines, perpendicular lines.